This is part 2 for lesson 9, exercise 3J. We are now going to be looking at method 2, elimination. Okay. So when solving simultaneous equations by elimination, one of the unknown variables is eliminated, hence why it's called elimination method. So one of the variables is eliminated by the process of adding or subtracting multiples of the two equations. This sentence will make sense once we actually just go straight into the example. So right now we have a set of equations. Here we have x plus y is equal to 3 and 2x minus y is equal to negative 9. The elimination process is a bit more tedious, to lack of a better word. And the reason why is because it's not just a simple substitution method where we can just substitute an equation into another one. We actually have to be a bit careful with our process, okay? Because there are more steps that are involved. So we're going to go to our mind map. Do both equations begin with a y equals? In this case, no. Does one equation begin with a y equals? Again, in this case, no. Are both equations in the format ax plus by equals c? Or in other words, a number in front of the x, a number in front of the y, and it's equal to a certain number? Well, yes. In this case, there is an invisible 1 in front of the first one, in front of the variable x. So there's 1x plus 1y is equal to 3. And then the second one is 2x minus y. So there's a minus 1 in front of here is equal to negative 9. So with this set condition, we can actually answer yes. Are the coefficients of x or y the same? Are the coefficients of x or y the same? This is saying that is there a number that's in front of the variable that is considered the same? Well, in front of the y for both of them, we do have a coefficient of 1. Even though the signs are different, there is a 1 in front of the y and there is a 1 in front of the y here. So you can answer yes. The coefficients of y are the same. Are the coefficients different signs? Well, they actually are. This y has a plus and this y has a minus, so these two signs, because they are different, I can answer yes. So what we're going to do is we're going to add the equations and then solve. And when we add these equations, the y itself will get eliminated. What do we mean by adding the coefficients? We're going to get, or adding the equations rather, we're going to get equation 1 and we're going to get equation 2. And we're going to add the two together. Now this seems like almost like a random process to just add these two equations. But mathematically, it can be carried out. So what we're doing is, this x here, which is just 1x, and this 2x here, we're going to add these two together. So we've got 1x plus 2x, we've got 3x. Okay. This y plus a minus y, I'm going to write this on the side here, y plus minus y. This right here is just technically turns into a minus. Y minus y is 0. This right here, this is an elimination that we're talking about. We're eliminating an actual variable itself because we don't want a variable there. We like to have our equations with just one variable, not both. So I'm not going to write plus 0, I'm just going to leave it blank because there's no point of just having a 0 there. And then this is equal to 3 plus minus 9. In this case, that will be negative 6. Cool. Now we're in a position where we can just solve for x. There is a times 3 associated with it, so we divide by 3, cancel, we're left with x on the left hand side. Negative 6 divided by 3, will give us negative 2. We're then going to substitute x equals 2, x equals negative 2 rather, and we'll sub this into equation. We can choose equation 1 or 2 because 1 has no coefficients in front of the variables itself. It looks like an easier one to substitute it into. So we're just going to substitute that into equation 1. So anywhere I see the letter x, I'm going to substitute it with the negative 2. So in this case, it's negative 2 plus y is equal to 3. We have a negative 2, so we're going to do the opposite, which is plus 2, plus 2. What do I do to the left? So I do to the right. So we're left with y is equal to 5. And that will be the y coordinate, that would be the x coordinate. So my solution is negative 2 and 5. When you substitute these values in to both of these equations, they will be correct. Okay. Specifically with this one, 2 times negative 2, which is negative 4, then take away another 5. So negative 4 take away 5 will give us negative 9. So this is correct. Okay, this will be the last example for this lesson. This is going to look at solving the pair of simultaneous equations 3x plus 2y. 3x plus 2y is equal to 2.3. So we've got decimals involved now. And 8x minus 3y is equal to 2.8. First things first, label each equation, so 1 and 2 respectively, and we're going to follow our mind map. Do both equations have a y equals? Nope. Does one equation begin with y equals? Nope. Are both equations in the form ax plus by equals c? Yes, they are. Are the coefficients of x or y the same? In other words, are these two numbers the same or are these two numbers the same? In this case, it is no. So we have to go to no. So what we need to do is multiply one or both of the equations to make the coefficient of x or y the same. In other words, we are forcing one of these numbers from the set of x or from the set of y to be the same. Okay, and this is where you have to apply a bit of thinking, because you can choose any numbers to either get the x's or the same, or you can choose numbers to get the y's the same. In this case, what I'm going to do is I'm going to multiply equation 1, all of equation 1, by 3. So when I do this, when I multiply this 2y specifically by 3, it will give me 6y. Now just keep in mind of 6y, keep that in the back of your head. The second equation, I'm going to multiply everything here by 2. So when I get to negative 3y times 2, it will give me a negative 6y. So we have a positive 6y and then a negative 6y. And because of that, we can then have these coefficients the same. We're trying to force these two numbers here to be the same. So we're going to get equation 1, and we're going to multiply equation 1 by 3. So 3x times 3 is 9x. 2y times 3 is positive 6y. And 3 times 2.3 will give us 6.9. We're then going to get the second equation, and like I was saying before, we're going to multiply the second one by 2. So 8x times 2 will give us 16x. negative 3y times 2 will give us negative 6y. And 2.8 times 2 will give us 5.6. So now I've got these two equations, and I'm going to label this equation 3 and equation 4. We've got two completely different looking equations in comparison to equation 1 and 2, but they are technically the same equations. They just look different. Okay. And the reason why we're doing this, like I was saying before, is we can force this to be a 6 and force this to be 6, meaning that we can now apply this step here. Are the coefficients different signs? Yes, they are. We can add the equations and then solve. So we're going to get equation 3 and we're going to add it with equation 4. You can see why the CASPAD calculator is a much more preferred method as opposed to this, because it is quite tedious. Okay, 9x, 16x, we're going to add these two together. We're going to be left with a 25x plus 6y plus minus 6y. Well, that's the elimination process, so these two technically disappear and turn into a 0, so I'm not going to write plus 0, I'm just going to leave it as is. And 6.9 plus 5.6 will give us 12.5. Alright, we have a times 25. Let's go ahead and divide by 25, divide by 25, and these two cancel out. So we will then be left with x is equal to 12.5 divided by 25. When you put this into your calculator, will give us a 0.5. Okay. Not exactly a whole number, but you can get decimal numbers and decimal answers when doing this. Alright, let's go ahead and substitute this value of x is equal to 0.5 into, let's substitute this into equation 1. Now I can substitute it to either equation 1, 2, 3, or 4. You can choose any equation. You will always get the same y value. When choosing which equation you want to substitute into, just look for the one that looks the easiest to substitute. In this case, it's not obvious, but because these coefficients are of a low value, as opposed to 3, 2, 3, and 4, this one looks the easiest. Okay, so everywhere I see an x, I'm going to substitute it with 0.5. So 3 times 0.5 plus 2y is equal to 2.3. 3 times 0.5 is 1.5 plus 2y is equal to 2.3. I have a plus 1.5 to get rid of, so I'm going to take away 1.5, take away 1.5, cancel, cancel. I'm left with a 2y is equal to 2.3, take away 1.5, we will be left with 0.8. Then I have a 2y associated, or times 2 associated, so I'm going to divide by 2, divide by 2, and what we'll be left with is y is equal to 0.4. So my solution over here, we've got x is equal to 0.5, and my y is 0.4. You can go ahead and substitute those two values back into the original equations to see if they work. They will. Even though we got decimal answers, these set of numbers will work. Okay, so if you're answering questions within the textbook and you get a fraction or a decimal answer, don't get discouraged. You can get those type of answers as well. And that concludes this lesson. For lesson 9, solving simultaneous equations. Go ahead and check your logbook, see what questions you need to do for this exercise.